Today's topic is finding the area between two curves. So before we get into that, let's go back and refresh what an integral is. So an integral is basically it's an antiderivative. It's a way to do the opposite of what derivatives do. So to work backwards, to undo what a derivative did. That's especially true if it's an indefinite integral. For a definite integral, it's going to give you the area under the curve. If we're finding a between two curves, we're going to do something similar. Before we do that, though, keep in mind what an integral is by its definition and how we calculate integrals and how we developed it. An integral was a Riemann sum, or is a Riemann sum, where we did the limit as, and there's a few ways to do this. Of our summation of I equals 1 to n of f of some x sub I star times r delta x sub n. We added more and more rectangles, and we did the area of each of those little rectangles. We added all together. Now, whenever we're going to do the area between curves, so here's our function f. We're going to find the area between them from A to B. A way to do that is to find the total area under the total area under G, and we're left with what we want. So the area here is going to be the limit as n goes to infinity of the summation of I equals 1 to n of star minus g at x sub I star times the delta x sub n. And now we're going to get the integral from A up to B of f of x minus g of x dx. Our f is greater than or equal to g for x being between, and it's for all x. Upside down A means for all x between that A and B. Now, what if that's not true then? Cross each other. Well, the area under a curve can be negative value. The areas up here are positive values. Area over here is also positive. However, when we say that we want the area between curves, we want it to only be positive. So if your two functions would cross, here, and so we want it to all be positive values. So a way around that is that we say we want the integral from a to b of f of x minus g of x inside an absolute value in order to get our overall. But we will handle that whenever we do some examples. So let's start off finding the. And first one, let's find the area bounded equals e to the x below by y equals x. And we're going to go from x equals 0 up to where x equals 1. So whenever we're dealing with these, it's a good idea to graph them. So there's where x, and let me make, there's where and y equals 3. So our first graph, e to the x. So it's going to be e when x equals 1. So that's a little bit better. There's our e to the x. That's just going to be our straight line. And we're going from 0 up to 1. And so we want this area here. Now, if you're not going to draw it, or if you can't draw it, for it's a difficult one to draw, there are still ways we can find our top and our bottom functions if they don't tell us what those are. So we know that they're going to go from 0 to 1. So the first thing we want to do is take our two functions and set them equal to each other. And then solve for x to see. So there's no solution for this. All right, so that's gonna make life a little bit easier. Next, we got to figure out which one is on top and which one is on the bottom. So since we're going from 0 to 1, I like to pick a representative between 0 and 1. So pick any number between those two and plug it into both of your functions. And then see which one's bigger. That one's on top. So e to the half is going to be bigger than 1/2. So we've established that e to the x is on top. All right, they told us this in this case, in this situation, so we don't need to do all this, but this is a good habit to get into whenever they don't tell you that. All right, so we're going to set up our integral from 0 up to 1. E to the x is on top minus x, which is on the bottom, dx. And now it's a fairly basic integral to do. minus 1 minus 0. So E minus 3/2. And let me make that look more like an actual 3. And there's our solution. Let's try another one. So now they just want the area bounded by y equals x squared and y equals 2x minus x squared. All right, so this one's a little bit different. They don't give us nearly as much information. They don't tell us which one's on top. They don't even tell us our bounds. So we have to find them. So this is where we're going to set our two functions equal to each other. And now let's solve. So be very careful when you do this. Now you can add your x squared over. And so we're going to get this. And then you could divide each side by 2. But please resist the urge to divide by an x, because then we're going to get down to this. But that's only 1 point. Rather, what we want to do is move everything to one side. N factor. And now we can set each of these. And so we know x equals 0 and 1. So over here, we lost one of our roots. So be careful. Never divide by an x or something with an x in it. All right, but now we have to figure out which one's on top. So let's take our two things and pick something in between. Let's pick a half. So if we would take 1/2 and square it, we're going to get 1/4. Then 2 times a half minus 1/2 squared, which is 1 minus 1/4, which is 3/4. So therefore, the 2x minus x squared is on top. And if you just think about this and what these are going to look like, x squared is just a parabola, but then 2x minus x squared, or rewritten minus x squared plus 2x. It's a parabola, but the x squared has a negative in front, so it's going to be opening down. Those lines. And so we want the area between the curves. All right, so let's find the area between them. We know it's going from 0 to 1 because those were our intersection points. We know that our 2x minus x squared is on top. Now, if you want to put these in parentheses, you can, and then put the other one in parentheses, you can. In this case, it makes no difference whatsoever. In other situations, those parentheses will make a difference, so it's a good habit to put them in. Then we can distribute the negatives, combine like terms. And now we have easy integrals to do. Going from 0 up to 1. And then this is a very easy integral to evaluate. 1 minus 2/3 minus a bunch of zeros. Therefore, our answer is just going to be 1/3. This one has a little bit extra involved in the process. let's try this. We want the area between, or the area bounded by these two curves. Let's do sine and cosine. Well, we want it from x equals 0 up to where x equals pi over 2. All right. That are two functions equal to each other. I don't know how we're going to figure this one out. Divide your cosine over. But that's only, don't divide it by an x if you're going to cancel. Cosine's not canceling, so it's okay to divide it over. Now, where is tangent equal to 1? If you remember your unit circle, it's going to equal 1 at pi over 4 and also at 5 pi over 4 and then at 9 pi over 4 and then at 13 pi over 4. Here's our solution. Although they're only worried about between 0 and 2 pi, so pi over 4 is the only one we have to worry about. Okay, so they will cross, or at least intersect, at pi over 4. So now we have two intervals that we need to worry about, because we know x equals 0 is an important number. And x equals pi over 2 is an important number. So on the number line, 0, pi over 4, pi over 2. We need to check each of these little intervals. So in here, we could pick pi over 6 and see which one's higher. And then in here, we could pick pi over 3 and see which one's higher. So pi over 6, sine is square root of 3 over 2, sine is 1/2. So cosine is higher on this interval. But then for pi over 3, they're reversed. Cosine's 1/2 and sine is square root of 3 over 2. So sine is higher over here. So we are going to need to do two different integrals. So our overall area is going to be going from 0 to pi over 4 of cosines on top minus sine, plus going from pi over 4 up to pi over 2, sine is on top. In there. All right. So now we have some fairly basic integrals to do. They're just trig functions. So we can go ahead and figure this out. That's going to be sine plus sine. Going from 0 to pi over 4. Plus, now we have a negative cosine minus sine. Going from pi over 4 up to pi over 2. So plugging things in, we get square root of 2 over 2 plus square root of 2 over 2. Minus plugging 0 in, 0 plus 1. Then plugging in pi over 2, we get 0 minus 1 minus a negative square root of 2 over 2 minus square root of 2 over 2. Distribute your negatives. 9 to give us square root of 2. These combine to give us square root of 2. So that's 2 square root of 2 minus 1. And if you want to be proper, when we're talking about area between curves, we should say these are units squared. All right. We're going to go that we want the area bounded by y equals x minus 1 and y squared equals 2x plus 6. X minus 1 is going to give you something along those lines. And then the y squared equals 2x plus 6 is going to so we want the area here. Now this one's going to be a little bit tough because if we're going to solve for y to set our two equations equal to each other, we're going to do a square root, which means it's a plus or minus. And so then we have to deal with this and then the square root of this and then the negative square root of this. And notice that there's a cutoff point about here where we have the negative square root below the positive square root. But then up to here in this area, we have the x minus 1 below the positive square root. So finding this intersection point or those intersection points might be a little bit difficult because we have square roots. Oh, there's a way that we can work around that. And then subtracting your square roots, and it can just get messy. An alternative is to flip our perspective. So we need between curves. So we always do top minus bottom. But how do you define top? If we would solve each of these, we can then set them equal to each other and do things in terms of y. So we're doing our integral with dy, not dx. And now top would be the farthest to the right because it's higher x values. And bottom would be farthest to the left because it's lower x values. So let's go ahead and do this. 1/2 y squared minus 3 equals y plus 1. Let's multiply everything by 2 just to get rid of fractions. And then let's move things all to one side. Multiply to a -8, but add to a -2. So now we know that our y is going to be between 4 . All right. Now, if we were done it the other way, our x values go from -1 to 5. So it is not too bad and things work out pretty decently. But at least this way we get to avoid square roots. All right. So now we have to figure out which one's on top, which one's on the bottom. So pick something that is between -2 and 4. Let's pick 0. When y equals 0, our first x will equal 1. Our other x will equal -3. So our y plus 1 is going to be our top. Integral -2 up to 4 of y plus 1 Put in parentheses if you'd like. And then minus 1/2 3. Now it's absolutely vital that this part is in parentheses whenever we do our solving. Because we're going to, speaking which, let's distribute that negative. Let's combine like terms. So it's a negative 1/2 y squared. Then it's going to be plus a y. And then whenever we distribute the negative, it'll be a plus 3. And then a plus 1. All right, so now we can take our integral fairly maybe a little bit messy because we have a lot of fractions, but fractions are going to happen. And now plugging things in, we get negative 1/6. And then 4 cubed is 64. Plus we get 6 minus 2 cubed is 8. So negative 2 cubed is negative 8. There's already negative in front. Then plus 4 2 and then minus 8. Let's combine things and simplify a bit. This fraction we can simplify. We can divide the 2 out, so that's a negative 32/3 plus 8 plus 16. Distributing that negative, this one will simplify to a 4/3. This one will simplify 8 plus 8 is 16, plus another 16 is 32. Minus that gives us 30. And then minus and a minus is minus 36/3, which gives us 30 minus 12, which gives us 18. And then if you want to be thorough, units squared. Then doing it with the dx's, make sure I use dy in there, is going to help you whenever you are about find the area between curves. So first, establish which one is going to be your independent variable. Next, get both of your equations in those terms, set the equations equal to each other. Find out where they intersect, if at all. If they do intersect, that might be your bounds. If they give you other bounds, you will make sure that they don't cross somewhere in the middle. Figure out which one is on top, which one is on the bottom by plugging in some value that's in your interval. Then once you have that, a definite rule and evaluate. It can be somewhat of a lengthy process, but none of this are necessarily that hard process, even if it can take of what you're doing with finding the area between curves, then the steps are fairly natural and they flow pretty well of here's the next thing that I need to do. Here's the next thing that would make sense to do. I have to do this before I can do anything else.